a principal consultant at 3S Green and SSS Consultants. He carries out design consultancy work in the fields of HVAC, intelligent building, automation systems, and green building, coming with a professional experience of over 4 decades in these fields. Mr. Subbu is a presidential member of ISHRAE and also a member of ASHRAE, AAR, IGBC, and FSAI. He is an alumnus of IIT Madras and a LEED fellow. He has also served as a senior trainer in Trane. Today, Mr. C. Subramaniam will talk about VAV Systems with zone temperature control to provide thermal comfort. So delegates, let's welcome Mr. Subramaniam.
The dimension which I want to talk about is somewhere on the integrated comfort system, controls and HVAC, how they play together to get what we want, what an end user expects, what an occupant expects in a location. In our journey towards smarter buildings, we have been talking about digitalization has played a very great role. Right from, for example, we had something like 1900s when controls were invented, HVAC systems were invented. Over a period of time, so much of things have happened. The technology improvements have happened in the equipment, what we buy for air conditioning buildings. So the earlier, possibly we were not having air conditioning because of some reason where equipments were not there, technology was not there, maybe the temperatures were not so high, or the population was less, or occupancy levels were less. But today, our occupant density is much high in a building, and our architects, the owners, people who are around, they want to have a live building. So you have an enclosed space, so built environment, it needs air conditioning. But when we talk about that, what happens? So the technology has improved for manufacturing of equipment and controls, and I think the future we are talking about IoT, digitalization and everything. Now, why do we need these kind of control, thermal comfort, which this very, very nice magazine is bringing out? It's because, what you see here in the screen is the 5 cycles of air conditioning. One is, this is the air side, now this is the chilled water side, this is the refrigeration cycle, this is the heat rejection cycle. And what you see in this purple line, that is, it is basically control system, which is uniting all this equipment and doing the coordinated effort. Now, why do we need this? Is because what happens is, in a building, it is, where the heat, you design the system, you design the MEP equipment, HV air conditioning equipment for addressing the peak load demand of the building. But that peak load is not there throughout the 3,000 hours of operation throughout the year, or 8,000 hours if it is a 24/7 operation. So which means all of these equipment have to go into different control modes at different climates. Be it summer, be it winter, be it monsoon, be it rainy season, whatever, of other seasons, it has to take care of that. And whatever heat that we are taking out from the built environment has to be rejected to the ambient. Be it, we can have multiple kind of systems, air-cooled and water-cooled systems, through the most energy-efficient method. And that is what, Vikram brought out in his presentation. There are creative ways of doing air conditioning, right? And so when we talk about built environment, so there is thermal comfort, the control systems play a great role. So while in the traditional level we have been having, and even today we have all these levels of controls which are behind the screen, but today, people expect data gathering, we want information, there is a lot of intelligence in the equipment. So there is a lot of importance on cloud-based analytical logistics that we are working about. We are talking about AI technologies. We are talking about cloud doing the data analysis and achieving the energy options and all that. So when we are talking about large building, so how do we do? It is something called, let's say we just take for example a built environment. This is how built environment is there. There are various ways of air conditioning the system. Now I'm just taking you through some of the methods by which we air condition in a normal commercial office space or a public space also, where there are multiple occupants. You've got cabins inside, you've got an open space, open office, and other meeting rooms and things like that. You want to address thermal comfort. So the one is we can have through varying the air volume which goes into the building. And then there are different ways of, doing it in a most energy efficient method, right? So that is what this slide we talk about. You've got multiple spaces. You've got something called a variable air volume system. You want to vary the air volume through something called as a variable air volume boxes. And they've got a lot of microprocessors inside this. And again, you've got an air handling unit which cools the air. It sends the cold air into the space. And there are controls and field devices and methodologies, programs which are going to achieve our thermal comfort based on the occupant requirement, be it a healthcare center or be it an commercial office space or a public space or whatever it is, based on what we want inside, temperature, humidity. Because when we talk about thermal comfort, we talk about temperature, we talk about humidity, we talk about noise, we talk about filtration, kind of pure air inside, and we talk about various other aspects. So all that we want to the CO2 level. We talk about the TVOC, the volatile organic compounds and all that. So all this can be handled through a proper energy efficient air conditioning system going in there. Now there is one more thing that we need to take care about when we are having multiple office spaces and we are putting, people are there inside the space working. So we need to have fresh air. Now Vikram mentioned about the ASHRAE standard and ISHRAE standard which define the amount of fresh air that we need to pump into the building, depending on the occupancy, depending on the type of activity that we are doing, if it's a library or if it's office space or if it's a factory air conditioning or some other whatever be the application, the fresh air quantity varies. But then we all know practically that all the people are not going to be in one single location right from morning to evening. Let's say office is occupied between 9 to 5. The people are going to move around. There may be some meeting rooms in some level. They go from here to there and they go from one meeting room to the other meeting room and things like that. But then when they go, we need to maintain comfort level. At the same time, we have to ensure that carbon dioxide levels are not going high and the fresh air is given to them at the required demand, whatever is required, and we achieve energy saving. Because we have to understand one thing important here. In a building, at the end of the month, the meter is on the building. We may have the best of equipment, best chiller or best VRF system or the best air handling unit, best controls, but the meter is sitting on the building. So we have to understand that the whole air conditioning system as a whole needs to be looked at, it's controlled to ensure occupant comfort, thermal comfort, which we are talking about. So I'm not going into the details of this, technical details, but what I'm saying is there are methods by which the control system ensures that the amount of fresh air is being given into the space based on the demand, because it may vary from location to location. And there are equipments also which can do this. You've got air handling units, you've got package units, you've got VRF system, you've got, and the state of the art, the technology has been improving, has been, advancing every day. So which means that they are all targeted towards one is energy, another is thermal comfort. How do we achieve both of them? So we have to match both of them. That is what is required. So depending on the application, depending on what kind of requirements are there, the system has to be designed. But whatever be the system, we need to have controls, because the load, the demand of the building, the cooling load, what we say, it is not constant throughout the year. It changes. So we need to have multi-modes operation of the building. Like what Vikram said is, there are some parts of the year where we can work just fresh air can be just pumped into the space as it is, or we can work on evaporative cooling mode. Then during only peak months that we need air conditioning, which is there. So this is again, you will have air handling units which are there, variable air handling system, which are pumping air into the build space with variable air volume boxes, because we don't want to unnecessarily pump more air when it's not required, because number one, you will not get thermal comfort. At the same time, you're going to spend more energy on it. Why do we want to do that? So all this will be possible provided. How do we achieve that? You have to have a proper design of the system. Plus, you have to have controls system also built in along with the equipment. Whatever system that we are putting in, be it VRF, be it chilled water system, it can be air cooled, it can be water cooled, it can be evaporative cooling, it can be natural ventilation, a mixed mode system. But you need to have proper field devices, you need to have a good building automation system which controls the temperature, humidity, and the CO2 levels, which are primary components of indoor environmental quality and comfort. Because your variable air volume system is going to take care of all kinds of complicated programs out there running in the controller, but it achieves your comfort inside. So that's what it gives you: low sound level, modulating controls and all that. And when you have a building automation system, BMS we call building management system, coupled with this, you can look into the building, in which room, in which space, what is the kind of temperature we are maintaining. Because these are the things which reflect your energy bills. So these are very important component, integral component of any building if you want to achieve thermal comfort as well as energy saving. And we can have mapping of your occupancy layout with temperatures. The floor heat map screen can be had today, right? And then floor lighting management system. And it can be coupled with air conditioning. So when a person moves out of his office space, not only the lights will go off in that cabin or meeting room, the air conditioning system also will go to something called as an unoccupied mode, so that when the person comes back after, let's say, 1 hour after attending a meeting in some other room, he will be able to get into comfort range, like 25 degrees Celsius, let's say, faster rather than switching it off. So there is something called occupied mode, unoccupied mode, and through building integration, through software integration of using ASHRAE, BACnet standards and all, we can achieve all this integration with the lighting management system. I think today challenges in building operations are faced, there are multiple challenges. There are a lot of opportunities, but challenges because facility manager looks at it in a different perspective, maintenance person looks at a different perspective. Now today we have the owner here, the occupant and tenant. Their expectations are different. Now how can we meet all of their expectations? It is through proper design of the HVAC system, proper design of controls required for that, and operations. Operations are very important. And today, one point which the Thermal Comfort Control magazine brought out is the IoT. Now, IoT is catching up very fast. There are a lot of things which are happening on the Internet of Things, and you have the volume of information is coming high. The velocity, the speed at which the information is coming, the variety of, because everybody wants data today. But what do you want to do with the data is what has to be properly analyzed, and we have to look at artificial intelligence, machine learning. We can talk about all this, but your fundamentals of heat transfers have not changed. How you want to achieve air conditioning, either through a small split air conditioners or through evaporative cooling or through chill water system, that has not changed. So I think we have got a lot of cloud IoT application. You've got multiple equipment coming, wireless equipment are available today. How will all of them sit together and operate as an integrated system is the challenge of the control industry, when we talk about the protocols and we talk about information technology. So those answers are available today. So through, what we call as an MQTT protocol, where data can be stored in the cloud. We don't have to store the data at the building level and things like that. So today, buildings are more complex. Owners want everything in their hands. And I think those are all possible with a good building automation system, good controls there, with well-designed HVAC. I think these are the things which I want to share quickly. Thank you for this, and we look forward to having you.